Hello everyone, you are welcome to this channel. Today we shall be solving some typical problems in engineering mathematics. So the problem one will be dealing with how to determine the moisture in laundry, and the second problem will be dealing with how to uh, know the temperature in the thermometer reading when it is cooling around the environment. So let's look at the problem one. It states the rate of moisture loss in a laundry is proportional to the amount of moisture present. So that is the physical law given. In 5 minutes, the wet laundry loses half of its moisture. How many minutes will the laundry lose? 70, how many will the laundry lose 70% of its moisture? Now let's solve this problem straight away. Now, as I used to say, to solve a typical modeling problem, you need the physical law guiding it. You need the model itself, the mathematics. You need to solve the model and you need to interpret the model. Now, in this question, we are given the physical law that what? The rate of loss of moisture in a laundry is proportional to its moisture present. So, let Y be the moisture present, the moisture present, amount of moisture. So, let Y be the amount of moisture present. So, the physical law states that what? The Y dt is proportional to Y. And what does that imply? It means the Y over Y is equal to K dt. Our K is the proportionality constant. So when we solve this, we have ln Y is equal to KT plus C. So and our Y is equal to what? Exponential KT plus C. And we can simplify this to be what? C star exponential KT. So let's put that as equation 1. That is Y is equal to C star exponential KT. Equation 1. So in order to get C and K, let's try to get C first. What are the conditions we need? At T is equal to 0, our Y then is equal to Y naught. Secondly, we are given that at T is equal to 5 minutes. We are given that at T is equal to 5 minutes, the wet laundry loses half of its moisture. So at T is equal to 5 minutes, that means the Y remaining is equal to 0.5 of Y naught. And the one we are actually looking for was what is the T at when the laundry has lost 70% of its moisture. So that is, we are looking for T when Y is equal to 0.3 Y naught, that is only 30% moisture remaining. So let's use this first condition to get C star. So that means from 1, at T is equal to 0, Y is equal to Y naught. That means our Y naught is equal to C star exponential 0. And that means our C star is equal to Y naught. And that implies our equation 1 becomes Y equals to Y naught exponential KT. So how do we get K as well? To get K, let's use this second condition. In the second condition, we have Y is equal to 0.5 Y naught. That means 0.5 Y naught is equal to Y naught exponential K times 5, because 5 minutes is that time when our Y is equal to 0.5 Y naught. So that means 0.5 Y naught divided by Y naught is equal to exponential 5K. And to do that, it means our 5K is equal to ln. So when these cut each other, we are going to have ln 0.5. So ln 0.5 will give us divided by, will give us what? K equals to ln 0.5 divided by 5. And that K will give us minus 0.139. Minus 0.139. So with that, our equation 1 becomes Y equals to Y naught exponential minus 0.139t. So that becomes our equation 2 now. So to now know the time when our 70% moisture will be lost, it means y then will be 0.3 y naught. So substitute this into equation 2. We have 0.3 y naught is equal to y naught exponential minus 0.139t. And that gives us 0.3 is equal to, why not we cut y naught, this cut this, and we are going to have minus exponential minus 0.139t, and then our ln 0.3 will be minus 0.139t, and with that our t will be 8.66 minutes, which is approximately 9 minutes. So that means in 9 minutes our laundry will be 70% dry. 70%. So let's go to the second question. In this question, we shall be looking at the thermometer. A thermometer reading 10 degrees C is brought into a room with temperature of 23 degrees Celsius. So let's look at this. So this is the thermometer. The thermometer, which is initially at T is equal to 0, is at 10 degrees C, and the room is at what? 23 degrees C. So this is the room. Let's say this is the room. It's at 23 degrees C. So after 2 minutes, according to the question, after 2 minutes, the thermometer reading is 18. So after 2 minutes, when T is equal to 2, the thermometer reading becomes 18. But the room is a big space, so it will remain constant at 23. So we are now looking for what time now? We are looking for the time. How many minutes will it take for the thermometer reading to become 23C? So we are looking for the time when it will be equal to 23C. So to know that, we are looking for when the time will be almost 23, approximately 23C here, but this will remain 23C. So the physical law has been given. Experiments show that the time rate of change of temperature T of a body is proportional to the difference between the temperature and the temperature of the surrounding medium. So that's Newton's law of cooling. So let's call the room temperature as Tr and the temperature of the thermometer to be T. So what the law is saying is that the rate at which temperature of the thermometer will change will be proportional to the T minus Tr. So that's the physical law. And to express it mathematically, we have dt is equal to k T minus Tr, where k is our proportionality constant. So we have now dt over T minus Tr is equal to k dt. And when we integrate this, we have ln T minus Tr is equal to kt plus c. So when we have this kind of case, we can further simplify T minus Tr is equal to exponential kt plus c, which can further be simplified to be exponential c star exponential kt, because c is always constant. So exponential c will also be constant. So we have now T is equal to Tr plus c star exponential kt. So let's put that as equation 1. So our task is to find our c as well as k. So at T is equal to 0, our temperature is equal to 10, and our temperature of the thermometer is 10. Our temperature of the room is what? 23. So we can use that in equation 1. Substitute that into equation 1. That means 10 is equal to 23 plus c star exponential 0, because k times 0 will be 0. So and that will be 1. So therefore which implies our c star is equal to what? Minus 13. That's 10 minus 23 minus 13. So we got that. So that means equation 1 becomes what? T is equal to tr minus 13 exponential kt. So let's put that as equation 2. To get our k, we can use the second condition, which is that what? At 2 minutes, the t has become 18. So it means that 18 is equal to tr is still remain 23 minus 13 exponential k times 2 minutes. You know, t is now our 2 minutes. So when we solve that, we are going to get our k to be 18 equals to 23 minus 13 exponential 2k, and that will be minus 5 equals to minus 13 exponential 2k, and 5 over 13 is equal to exponential 2k. So, and that will give us our k to be minus 0.4778. So, having done that, that means our final equation, equation 2 becomes now t equals to tr minus 13 exponential minus 0.4778t. So, with that, we are now looking for when the temperature of the room is going to be equal to the temperature of the thermometer. Good. If you do that, that will be 23. This will become 23, which also remain 23 minus 13 exponential minus 0.4773 t. But the problem here is that if you say 23 minus 23, that will be 0. That will be 0. So 0 will be what? Minus 13 and so on and so on. So if you are going to find the lane of 0, it's going to give you error. So what you can do is that you don't choose t to be 23. Choose it as something very, very close to 23. So that will be 20, let's say 22.9. So that will be 22.9 is equal to 23 minus 13 exponential minus 0.4773t. And if you subtract that, that will be minus 0.1 divided by minus 13 equals to exponential minus 0.4773t. So with that, you are going to have lane that and t will give you 10.187 minutes. So instead of running into the error of a calculation of negative, I mean 0 lane, it's better you move close to that number so and calculate your values. So the time then will be 10.87. That is the time when the temperature will be very, very close to 23 minutes. So approximately 10.5 minutes will take it to reach the temperature of the room. I hope this is very clear and you enjoyed the lecture. If that's so, please subscribe to the channel. And if you have any comment, please let me know behind the page. Thank you.